In an audio system, the amplifier is the component which makes the sound louder and sends it to the speakers. While most amps on the market are powered by transistors, many audiophiles swear by tube amplifiers, which use older vacuum tube technology. Many believe that tube amplifiers produce a warmer, more natural sound. This factory makes the amp's main chassis from a sheet of polished stainless steel. A computer-guided punch press cuts openings for the power switches, control knobs, and other components. The press prepares 8 chassis per sheet. Workers separate them with a few strikes of a mallet. Then they place them one at a time in a bending machine called a press brake. Once they position the sheet with the help of metal guides, they activate a foot pedal, releasing 90 tons of pressure to bend the edge of the sheet. Then they remove the adhesive film which has been protecting the mirror finish surface of the chassis. They clean off any remaining adhesive residue with alcohol. Then they put the chassis into an offset press. Using a silkscreen printing process, it labels the controls and connections. Next are the speaker terminals, which connect the speaker wires to the amp. These connectors are made of gold-plated brass, which are non-magnetic metals. Magnetic ones would react to the electric current and cause distortion. The terminal circuit board, installed next, carries the amplified signal from the main circuit board to the speaker terminals. They install and connect the power switch and the circuit board for the vacuum tube illumination. This indicates the tube's status. Meanwhile, this machine winds strands of copper wire around plastic bobbins to begin making the amp's output transformers. Output transformers match the amp's circuitry to the electronic specifications of different types of speakers. The number of wires, their different gauges, and the number of revolutions around the bobbin create this unique compatibility. After taping the wires to prevent unraveling, they join, then solder the ends to additional wiring. They will later connect to the amp's main board. A fiberglass sleeve insulates the connection. They place the bobbin in a lamination machine. Laminations are thin plates of carbon steel. The machine stacks them all around the bobbin. Then workers put a bolt in each corner to hold them together. They place the laminated bobbin in an aluminum housing and pour in hot black tar. This immobilizes the laminations, so they won't rattle when the amp is amplifying low frequencies. Then, workers install the 2 output transformers into the chassis, along with a 3rd transformer to power the amp. They take the amp's main circuit board, plug in ceramic sockets for the vacuum tubes, and solder the socket's leads to the board. Then, after feeding the transformer leads, they mount the main board in the chassis, screwing it to posts to hold it in place. Then they connect the transformer leads. They plug the vacuum tubes, one by one, into the sockets. The tubes are made of glass with a heat-resistant base. The interior contains a combination of metals, but no air, hence the term vacuum tube. The amp has 11 tubes in all, 7 small ones to power input signals from a source, such as a CD player, and 4 big ones to power output to the speakers. Then they attach the chassis' ventilated bottom cover made of painted steel. They affix decals to differentiate the output transformers from the power transformer. LED lights turn green when the amp is powered up and ready to deliver that warm, natural sound that many believe only traditional vacuum tubes can produce.